With our acceleration setup, we're now going to handle turning our kart. If we go back to our kart controller, at the top of the file, we're going to add a few more objects that we're going to start working with in a moment. So we are going to implement to get the front left wheel. We are going to take the front right wheel and the handle, and based on the current rotation that how much we're going to turn, the handle here and the two front wheel will turn as well. Next, we're going to implement in a similar way that we did for the acceleration. We're going to implement the variable for the rotation. So it's going to consist of steering, how much we can actually turn, what is required. The handling is just to smooth how the steering will operate. We are having the requested rotation, the next rotation, and our current rotation. For rotating the kart, to rotate the wheel of the kart, I am going to use my left analog stick on my gamepad. So I'm going to create a new callback function that is going to be called on gamepad axis. And what I like to do usually when I'm dealing with gamepads, the left, sometimes those analog stick are pretty jittery. So in order to ensure that the user actually push the left analog stick, I always like to check a specific threshold. Like in this case, I am checking if my left analog stick value, absolute value is greater than 0.05. Like that, it ensures me that the actual left analog stick have been pushed by the user and is not just jittering like that. So what we're going to do is we are going to calculate the power, the steering power, which is going to be our current speed that we're running, multiply by the steering that we're having here, multiply by our handling. And like that, the faster we go, the faster we will turn, the slower we go, the slower we will turn. And we're going to affect that to our rotation, similar as we did for the speed, but this time is going to be our rotation plus the power multiplied by our application delta time, and then how much we actually want to turn, the value that it's coming from our left analog stick. Next in update, I'm going to need to interpolate my next rotation. So my next rotation would be a linear interpolation between my next rotation, the current rotation, and the application delta time, just to smooth things as we did earlier. It's a bit redundant here, but it just, feels better when you're turning. And you'll see what I mean in a moment. Next, I am going to actually handle the kart rotation. So for rotating the kart itself, I am going to use the following code. I am going to initialize a 3x3 rotation matrix, and I'm going to set that the Z rotation of this matrix is my current rotation. Then I will calculate my current rotation, which is equal to my current rotation plus my next rotation, the one that I've been interpolated. And this is what we're going to use to rotate the handle and the wheel. Then I assign to my kart basis matrix, I am going to set that 3x3 matrix as the rotation. And if you remember, when we're calculating the forward vector, we are actually using, I can replace that. We are using the model matrix, which is going to be on the next update, actually, since we are dealing first by updating the basis matrix and then the updated model matrix. And wherever our kart is looking at, this is going to give us our forward axis. The next thing that we're going to do is, now that we can turn, we also need to turn our camera. And if you remember, under geometry and constraint, we have created a elliptic constraint, which is basically a fancy way, like for orbiting the camera around a target, a fancy way to say. So what we're going to do, we're going to go pull from our camera that we should initialize at the top, which is local camera equal to my scene get object, and I'm going to just copy paste that geometry, which is my main camera here. And what I'm going to say is get the constraint elliptic, same name as this, data elliptic, and then angle Z is my current rotation. So wherever my joystick, my current rotation handled by my joystick is turning, I am going to rotate the camera accordingly. And now I'm going to turn those front wheel and handle. So similar as we did for the back wheel, we are going to this time calculate. We're going to take the left. We're going to start with the left wheel here, and we're going to extract the Euler angle, and we are then going to add our current speed to make it turn forward or backward, and we are going to use our next rotation to actually rotate it in the good way. So we're not only making it turn forward or backward, we're also going to tilt them in the direction that we are turning. Same thing for the right front wheel, and similar for our handle as well. We're going to use, except that the handle is not moving forward or backward, it's simply turning on itself. And now we should be able to compile. And as I go forward, I can now use my gamepad to control in which direction my kart is actually going. And we have our interpolation that is kicking in. So we are smoothly cruising with our kart and our wheel turning. Ooh. All right. And we're going to do that for a little while just to check how it feels. Of course, you can at any time change the rotation, the handling, or the actual acceleration of your kart, just to make it feel more right based on your requirement. And we're going to go all the way and stop somewhere here. Here we're going to start to have a little problem. As we climb, you see the kart just simply enter our ramp here. And what we want to do is to actually make it tilt according to the terrain that our ball is currently running on.